really pushing the boundaries too.
And this is leading to more innovation, more patents.
For sure, the patent race is heating up. There was a 13% increase in QT patents granted in 2024 alone. IBM and Google hold the most right now. And interestingly, if you look by country, China's leading in quantum computing patents, while the U.S. leads in quantum communication patents.
Communication suggests a focus on security, right?
Exactly. Which brings us nicely to that second pillar.
Right, let's zoom into quantum communication. The report talks about Q-Day. That sounds ominous. The day current encryption gets broken. How does quantum communication actually secure our data against that?
Yeah. Q-Day is the shorthand for that potential future threat. It's the point where a sufficiently powerful quantum computer could, theoretically, break the encryption methods we rely on today for everything: banking, secure websites, government communications.
Everything.
Pretty much. Now, the quantum communication market itself is projected to grow significantly from about $1.2 billion in 2024 to nearly $15 billion by 2035. A big part of that is post-quantum cryptography, or PQC.
PQCs. Okay.
PQC is actually the most commercially mature area right now. It's all about developing new cryptographic algorithms, new math problems, basically, that are believed to be secure even against attacks from future quantum computers. It's about future-proofing our digital security.
So building the new locks before the quantum key exists.
That's a good way to put it. Governments are the biggest buyers currently, about 57% of PQC purchases in 2024, which makes sense given national security implications. But we're seeing much more private sector uptake now, especially in telecoms and finance.
We've covered computing and communication. What about that third pillar, quantum sensing? What makes its measurements so special, and where could we actually, see it being used?
Quantum sensing is fascinating because it leverages those weird quantum effects, superposition, entanglement to measure things with just incredible sensitivity and precision. Think orders of magnitude better than classical sensors.
Like what sort of things?
Well, NASA just had a breakthrough demonstrating an ultra-cold quantum sensor in space for the first time. That could revolutionize things like navigation where GPS isn't available, or even testing fundamental physics. But closer to home, imagine medical imaging that detects tiny biological markers much earlier, or geological surveys that find resources with pinpoint accuracy, or even quality control in manufacturing at an atomic level.
So really precise measurements across many fields. Okay. Stepping back then, what's the bigger picture here? How does all this quantum tech connect with other big trends people might be following, like AI or robotics?
Right. It definitely doesn't exist in a vacuum. QT unlocks some really powerful synergies. Quantum computing, for instance, has the potential to dramatically speed up the training of complex AI and machine learning model, or to create much more accurate climate simulations.
Okay, so accelerating AI.
Exactly. And think about robotics. Robots could be crucial for actually building these incredibly precise, complex quantum machines. But robots themselves could also benefit from hyper-secure quantum communication networks or super-sensitive quantum sensors for navigation and interaction.
Interesting. And cybersecurity, obviously, we touched on that with Q-Day.
Yes. Cybersecurity faces both a massive new threat from quantum computers breaking old codes and powerful new tools like PQC and quantum communication for protection. It cuts both ways. Which really leads to the important question for everyone listening. How might these interconnected technologies reshape your specific industry or field?
That's a powerful question. What an incredible deep dive this has been. From the surging investments and these huge government bets to the breakthroughs in just making qubits stable and fixing errors. It's really clear quantum isn't just a lab concept anymore.
Not at all. The momentum is real.
It feels like a rapidly accelerating reality, doesn't it? Poised to reshape so many industries, finance, healthcare, materials, you name it, while also being key to securing our digital future. So here's the final thought to leave you with. As this quantum technology moves out of the labs and into widespread real-world use, how will you start thinking about leveraging these advancements? Or maybe, how will you need to adapt to the profound changes they're likely to bring, both in your work and, well, maybe even your everyday life?